So in example 8, we're going to apply what we've just learnt to multiply these two complex numbers. I don't know whether it's printed incorrectly in your textbook, but this should say Z2 equals this complex number here. So I'm actually going to do part B first. And I'm going to just quickly write down what happens when you times these two complex numbers together. So remember these formulas which we learnt in the last video. So to times two complex numbers together, we know that the modulus of the product, we're going to times together the moduluses of the two complex numbers. So we're going to do 3 multiplied by 4 to get 12. So the modulus of the answer is 12. And then to find out the argument of the product, we're going to add together the two arguments, θ1 plus θ2. So in this case, we're going to do 5 pi over 12 and plus pi over 12. And then we could simplify that, leave the modulus as 12, or we can simplify the argument. 5 pi over 12 plus pi over 12 is pi over 2. Okay, and then for part 2, we've got to write this in this form, this x plus iy form. So we're going to make it really clear what's the real part of this complex number and what's the imaginary part of the complex number. So if you've got a complex number which is in modulus argument form and you want it in this form, x plus iy, then all you need to do is expand out the bracket. So you could just say that's 12 cos of pi over 2, just do that times that, and then do that times that, so plus 12 times I sine of pi over 2, and you can see that we've got it in that form, real part plus I times by the imaginary part. So let's simplify that a little bit more. Cos of pi over 2 is 0, so we've just got 0 there, and then plus I times 12 times sine of pi over 2 is 12. So we'd normally write that as just 12i, 0 plus 12i, which is just 12i. So you can see that the real part of Z1, Z2 is 0, and the imaginary part is 12. Let's go back to part B then. In part B, we were asked for this value here. So this is the modulus of Z1, Z2. Well, the modulus of Z1, Z2 is 12. That's that value here. And we got that by timesing the modulus of Z1 by the modulus of Z2. We did 3 times 4. So a formula that is useful is we get that by doing the modulus of Z1 times by the modulus of Z2. And this is quite a useful formula to remember. So in our case, Z1, the modulus of Z1 times Z2, we did 3 times 4, which got us 12. And we could work out the argument of Z1 times Z2. Well, the argument of Z1 times Z2 is this part here inside the bracket. And the way that we got that is we added together the two arguments of the complex numbers that we're timesing together. So we did argument of Z1 plus the argument of Z2. So in this case, we did 5 pi over 12, that's the argument of Z1, plus pi over 12, which is the argument of Z2, and we got our final answer when we simplified that of pi over 2. That's the argument of the product. Although it's not asked for in the question, I think it is useful to see what the geometrical significance of this is on the Argand diagram. So I've sketched Z1 and Z2. Z1 is a distance of 3 away from the origin, and Z2 is a distance of 4 away from the origin. Z1 has an argument of 5 pi over 12, and Z2 has an argument of pi over 12. So when we times these two complex numbers together, we get a new complex number, which has an argument of the sum of these two. the sum of these two is pi over 2. So that's straight up. So we know if we sketch this new complex number, z1 times z2, we know that it's going to be up here somewhere. Let's sketch that. So somewhere there, z1, z2, because that is pi over 2. We've added together those two arguments. And we know that the distance away from the origin is going to be 3 times 4, so it's going to be 12 away from the origin. So that's our complex number z1, z2.